Alrighty, so let's go ahead and look at this problem below. A juice box has a volume of 22.5 cubic inches. If the area of the base is 5 cubic inches, what is the height of the juice box? Well, first, let's think about if we are given the volume of 22.5 cubic inches, and we are given the area of the base is 5 cubic inches, and the question is asking what is the height of the juice box. A lot of the vocab words that I'm hearing remind me of a formula that we talked about yesterday. What formula would I need to start solving this problem? Well, if I look closely, I see that they've already given me a volume of a juice box. So I know that I need to find volume. So I'm going to go ahead and write that down. We need the volume of this shape. Well, now what is the shape of a juice box? Well, if I just drew it out really quickly, I know that if we had a juice box sitting here off to the side, it would be in the shape of a rectangular prism. Right? A rectangular prism is the shape of a juice box. And so what volume formula do I need for a rectangular prism? Well, if I look over at my star chart, I see for volume that there are two different types of formulas. So since we are looking at a prism, then I will be using our volume formula, capital B, H. So let's go ahead and write that down. Capital B, H. And so I know we talked about this formula yesterday, so let's go ahead and just quickly review what each of these variables stand for. So I know V is for volume, and I know H is for height, but there was something very special about this capital B that I need to remember very carefully. The B is capital because we need to find the area of the base first, and then we can multiply it by the height. So it's not just the base length, it is the area of the entire base shape. So we want to make sure that's written in our notes. Awesome. So now that we have these pieces, we can go ahead and start substituting what they've already given us. So I see the volume is 22.5 cubic inches. So I'm going to label that here, 22.5 inches cubed. I see that the area of the base is 5 cubic inches, which would be capital B. So 5 cubic inches, which actually I believe that's incorrect. It should be squared inches. And they are looking for the height. So I'm going to put a question mark next to H, right? That is what is missing. Therefore, that is what we're trying to find. Awesome. Now that we've labeled that off to the side, I'm just moving our formula over. We can begin substituting that directly into the same formula we used yesterday. So our volume is 22.5, our area of the base is 5, and our H is missing, so we're going to leave that there as a variable. Perfect. Well, I know that yesterday we multiplied the area of the base and the height to get the volume. So what are we going to do to work backwards? Well, we know how to solve equations, so we're going to use the inverse operations, and the inverse of multiplying is dividing. So we're going to divide both sides by 5, so we get the variable by itself. So here we go, using bow tie, bottom out, top in, bringing up our decimal and drawing our seats. I can begin to divide to see how many times 5 goes into 22.5, and I see it as 4.5 times. So now that we know what H is, we can answer our question. It says, what is the height of the juice box? Well, we determine the height of the juice box is 4.5 inches. So to stamp, our volume formula can be used to both find volume of shapes, but also to find height or missing dimensions of these shapes when we are given the volume. So it is very important that we find the formula, we annotate what is given from the problem in a list, and then we substitute that in so we can begin to solve for whatever is missing. We're going to try some more independently.